Good evening, Earth Science students. Today I'm going to go over contact and regional metamorphism. So please put down your table of contents to analyze the impacts of contact and regional metamorphism on rocks. You have your guided notes. Make sure you keep up and copy down the blank spaces in your guided notes. Okay, so two types of metamorphism. We have first one is contact. Contact says when the heat from magma touches a rock, causing it to change. In this picture, we have contact metamorphism happening. So where you have existing rocks, pre-existing rocks or parent rocks, these parent rocks can be changed when you have a magma chamber or a hot source close by. For regional metamorphism, when tectonic plates collide, it creates tremendous heat and pressure which causes the rock to change. We will learn more about plate tectonics in the next unit after this. But when plates do collide, it's called convergent plate boundaries. And at those boundaries, you would have a lot of heat and pressure building up, and parent rocks or pre-existing rocks can change into metamorphic rocks. So let me start off by this picture. So this picture is a great example of contact metamorphism. So this dark spot here is most likely the heat source. It was once part of a magma plume that maybe rose up near the surface, and the heat changed the rocks on both sides of this intrusion. So you can see like a darker patch here. I'll outline it here. That's a dark patch. And there's another dark patch right down here. So right where those dark patches are, you would have your contact metamorphism. So as an example, if this rock was a sandstone, that sandstone could be changed into a metamorphic rock called quartzite. Okay, so contact metamorphism. The intense heat from a magma chamber changes the structure and sometimes the mineral composition of the surrounding rock. The area of metamorphism is relatively small compared to regional metamorphism. So going to page 7 of the reference table, under the scheme of metamorphic rock identification, we have contact, which is highlighted for you here and here, and we have hornfells, which is a type of contact metamorphism. And the pre-existing or parent rocks are just various rock types that are not listed here. So maybe a piece of gabbro may evolve into a hornfell. Maybe a piece of rock salt may eventually evolve into that. For this here, we have regional or contact, so they both can be similar. And we have quartzite. So if we have sandstone as the pre-existing or parent rock, sandstone can turn into quartzite. If we have limestone or dolostone as the parent rock or the pre-existing rock, that can turn into marble. Now, metaconglomerate is what it changes into. It says here, pebbles may be distorted or stretched. So, it could be sediments. And also in the word conglomerate, we learned about a conglomerate for the clastic sedimentary rocks. So, perhaps the conglomerate rocks can turn into a metaconglomerate. So we have various minerals for the hornfells. We have quartz for quartzite for the composition. We have calcite or dolomite for marble. And metaconglomerate, we have various minerals. All right, regional metamorphic rocks. The changing of rocks due to an increase in heat and pressure over a much larger area, excuse me. Occurs where tectonic plates interact and mountains are formed. So looking at this picture, we have an oceanic plate, or oceanic crust, which is more dense because it's sinking. This is colliding with a continental crust on the left. And because this rock is sinking, a lot of heat and pressure is built up where the two rocks are interacting, right? So a lot of friction is going on. And sometimes rocks can become too, it can be very heated, very hot, and it can change into a liquid form, which automatically means it's making a transition into an igneous rock. And then once it turns into a liquid rock, molten rock, because of its density, it would rise to the surface, and therefore you would have contact metamorphism going up toward this volcanic peak. Alright, so going to page 7, scheme for metamorphic rocks. We have a lot of rocks that are regional. So let's begin over here by the foliated. These rocks we have slate, and the parent or pre-existing rock of slate is shale. So if you have a shale rock layer under increased heat and pressure, shale can turn into slate. And this arrow that's going down, that indicates more heat and pressure. So under more heat and pressure, slate can turn into phyllite. More heat and pressure, phyllite can turn into schist. More heat and pressure, schist can turn into a piece of gneiss. A piece of granite can also, under heat and pressure, form into a piece of gneiss. Slate, of course we know here slate is the only monomineralic foliated rock because it only contains mica. Phyllite, schist, and gneiss are polymineralic rocks, right? Because they contain mica, quartz, feldspar, amphibole, garnet for the most part. And then pyroxene is in both gneiss and schist. Anthracite coal. If we have bituminous coal, which is a sedimentary rock, as the parent or pre-existing rock, right, that can turn into another type of coal called anthracite coal. And just how we had the contact, quartzite, marble, metaconglomerate, all can be considered regional also. It could be regional or contact. And those rocks are the non-foliated rocks. So under heat and pressure, right, so we have parent rock, not distorted. So a piece of sandstone that's not distorted, parent rock, pre-existing, can turn into quartzite. So this is an example of plate tectonics, two plates interacting. Oceanic plate is moving to the left, and this continental plate is moving to the right. Under heat and pressure, dolostone can turn into marble. Limestone can turn into marble. And then we have the sequence from page 7. So shale can turn into slate. More heat and pressure, slate can turn into phyllite. More heat and pressure, phyllite can turn into schist. And more heat and pressure, schist can turn into gneiss. And some of the various rocks, as an example, let's say siltstone. Siltstone can turn into a hornfels. right? Because there's a lot of contact going on here next to this chamber, magma chamber. Alright, last part is density versus pressure. We know on page 1, and we had a lab on this, lab number 3, we know that density equals mass over volume. And when we're dealing with pressure, pressure's the ability to squeeze something, right, and adding pressure all around it to make it smaller. So volume decreases when you increase pressure. In this example, mass remains the same. No additional materials were added when the original mass is compressed. So even parent rocks, it's the whole entire parent rock, but no additional rock was added to it. Alright, so I'm going to give you a little demonstration here. Now in your guided notes, you have boxes covering this. You're going to fill this in. So before, we have D equals M over V, right? Mass over volume. So let's do an easy example. Let's say the mass is 8 grams and the density is 4 centimeters cubed. Alright, so 8 over 4 will give us a density of 2 grams per centimeter cubed. Now afterwards, right, we have a lot of pressure going on here after. Right, a lot of pressure on all sides, making this box-shaped rock smaller. So let's say we make it smaller. Let's say that the volume now is cut in half. So now the original volume was 4 centimeters cubed. Now the volume was cut in half, and half of 4 now is 2 centimeters cubed. Alright, the mass stays the same because we didn't add anything to it. All we did was just put pressure on this material. Alright, so now 8 grams over 2 centimeters cubed will give you a density of 4 grams per centimeter cubed. So whenever you add pressure to a rock, and the rock recrystallizes to form metamorphic, you're increasing the density of the rock. It becomes denser. And because of its high density, these rocks are really impermeable. Because now, if it had pore spaces, now there's minimal pore spaces because it's so compressed into a smaller area. Alright, so to summarize this presentation, you should be able to know, okay, there are 2 types of metamorphism, which is contact and regional. The word parent rocks, igneous, sedimentary, or metamorphic, are altered with increased heat and or pressure. Contact results from magma chambers. Regional results from the movement of tectonic plates. Alright, for contact, we're looking at high heat and little pressure in a small area, of course. Regional, we're looking at high heat and high pressure and a larger area. And the last part, regional metamorphic rocks result in the densest rocks. Alright, that summarized this presentation. In class tomorrow, we're going to have an activity based on identifying what parent rock, looking at the parent rocks, what they can turn into, right? Basically interpreting diagrams and knowing where they occur, where does contact occur, and what these rocks can turn into. Alright guys, have a good night and see you tomorrow. Bye-bye.